In example 13.1, we're going to be using definition 13.1 to help us to identify some information about some polynomial equations. So it says here that each equation given is a polynomial, so I'm not trying to trick you here. Everything's a polynomial here. It says complete the table by determining the leading term, the degree, the leading coefficient, and the constant term. So there are several things that we need to find. I always start with the leading term because the leading term is going to help me to figure out what's the degree, and it will also help me to figure out what is the leading coefficient. The only thing that the leading term doesn't help with is finding the constant. So the constant is just sort of its own thing. It's the only term that doesn't have a variable involved, so it's usually pretty easy to identify. So for the first equation, f of x equals 42. All I have is just one term here, 42. That's it. And there's no variable involved, so this represents a constant function. We know that the degree of a constant function is 0, and I mean, the name itself, constant function, leads us to believe that that's a constant, and it is. So 42 represents the constant term. Well, as it turns out, since it's the only term, it also gets to serve as the leading term, and it also gets to be its own coefficient, and so it also represents the leading coefficient. So this is the only function where your only term gets to be representative of all the different things that we're looking for. All the other equations will have multiple terms, and that won't be a concern. So moving on to g of t equals 5 minus 4t. So with this, I want you to view this as having two terms. We have the 5 and the 4t with subtraction in between them. And the language leading term can be a little misleading. Leading term does not mean it has to always be written first. It should be written first according to our polynomial definition, but that doesn't necessarily mean that it's always given to us that way. So the leading term is always the term that has the highest power on the exponent. That's where we get the degree. So in this case, the 5 is not going to be considered the leading term. The leading term is going to end up being this minus 4t. So we'll say the leading term is negative 4t. The implied power on that t is 1, so the degree of this equation is just 1. The leading coefficient is the coefficient that goes with the leading term, so we just copy down the negative 4, and then the constant in this case is actually what's written first, is 5. The next equation is k of x, and k of x should look really familiar from section 12. This is a vertex form quadratic equation. And the trick here with doing these problems is that we want the equations to always be written in standard form, which is what the polynomial definition is written in. That's a standard form for a polynomial. So I'm going to take k of x and I'm going to multiply it out so that way I can actually see the individual terms and not have them in this specialized vertex form. So I'll start with the exponent here. So that's going to be x squared minus 6x plus 9. Then I will multiply through by 7, giving us 7x squared minus 42x plus 63. And then I tack on the plus 2. I can go ahead and combine those two constants together at the end, giving me k of x equals 7x squared minus 42x plus 65. So this would help me to recognize that 7x squared is going to be my leading term, making the degree 2, which I already knew the degree was 2 because we had stated that this was a vertex form quadratic equation. Quadratic equations are always degree 2. But it's good to see that it's backed up there when we get into standard form. Lead coefficient would be 7. The constant is not going to be just plus 2. It's going to also have that plus 63 with it, so 65 is what becomes our constant term. So that's probably the biggest thing that you end up missing if you don't convert this into standard form, is the identification of that constant. H of x, next one. H of x is 5x plus 12x squared minus 2/3 of x cubed and minus 7. So as I mentioned earlier, it's not necessarily always going to be given to you with the leading term written first. And this is no exception. The leading term is actually written third. It's the negative 2/3 x to the 3 term. That's the highest exponent that we see, telling us that the degree of this polynomial is 3. The leading coefficient is negative 2/3, and your constant is negative 7. F of x is equal to 2x to the 4 minus 3x cubed plus 1/3 x. The leading term is 2x to the 4. Degree would be 4. Lead coefficient is 2. And the constant doesn't seem to be showing. So the implication is that the constant must be plus 0. So we'll just write down 0 as the representative for the constant. And the last equation, we have g of x is equal to 3x squared times x minus 2 times x minus 3 squared. So I want to copy this equation down, and I want to give another look at it, because this is also not in standard form. This is known as factored form. And there will come a time here very quickly where we are interested in the factored form over the standard form. But it is important that you know how to be able to go from one form to the other. So when you have it in factored form, it makes it a little challenging to be able to answer these questions unless you've had a lot of experience with polynomials in the past. So what I'm going to suggest is that we take it out of factored form, put it into standard form by going through all the appropriate distributions here, because it's all just one big multiplication problem. So I'm going to break this task into 2 multiplications here at the beginning. I'm going to multiply 3x squared with the x minus 2, and then I'll multiply x minus 3 squared. And then once I get those results, I can take that further. So let's start with these introductory multiplications. Distribute 3x squared with x minus 2. You will get 3x cubed minus 6x squared. And then I'll take x minus 3 and square that to get x squared minus 6x plus 9. And now I'll have to go through the long distribution process. 3x cubed will multiply to everything x squared minus 6x plus 9. Same thing happens with the negative 6x cubed. It has to multiply to each of the x squared minus 6x plus 9. So understanding how that distribution works gives you, tells us that we're going to have 6 terms once we're done with the multiplication. So multiplying out, I'm going to start with the 3x cubed. I'll have 3x to the 5th minus 18x to the 4 plus 27x to the 3rd. Now moving on to the negative 6x squared. That's going to give me negative 6x to the 4 plus 36x cubed, and then looks like minus 54x squared. So I should be able to count 6 terms. So let me double check. 1, 2, 3, 4, 5, 6 terms. So all 6 are there. But what I want to do now is check to see, do I have any terms that are considered like. The first term does not have another term that's like it, so I will just copy down 3x to the 5th, 18x to the 4, 6x to the 4. Now those are both negative, they both have subtraction, so when I combine those together I'll end up with minus 24x to the 4. Same idea happens with the x cubes, 27, 36, those are both positive. That's going to result in 63x to the 3rd. And then finally the last term doesn't have another like term with it, so I'll just copy it down. So this gives us the standard form for g of x, giving me 3x to the 5th as the lead term, 5 is the degree, the leading coefficient is 3, and the constant term is implied to be 0.